Hey guys, welcome to task 4.6, reviewing the Ferris wheel from our homework 4.0 and learning how to graph sine. I just want to remind you guys to make this video as useful for you as you can. Pause it when you need to pause it, fast forward, rewind, whatever you need. If you haven't messed around with the playback speed, definitely do that. In the bottom right-hand corner, there's a little gear. If you click on it, you can change the playback speed. 1.5, 1.7 will make it go a whole lot faster. Just under 1 will make it go a little bit slower. If you think I talk too fast, there you go. You can slow it down. If you think I'm not talking or moving fast enough, please speed it up. Make this super useful for you. But let's go ahead and dive into the task now by looking at the Ferris wheel problem that was presented to you in the 4.0 homework. You are writing a Ferris wheel. And on that Ferris wheel, there are a few details that we're going to remind ourselves of. So first and foremost, this is what your task looks like, just making sure you're on the same thing as me. Let's remember all of those details about this Ferris wheel. The Ferris wheel starts at position A and makes a circle around the wheel back to position A. It rotates in the positive direction, and that one full rotation is 20 seconds. The Ferris wheel also has a radius of 25 feet. That's why you see each of these spokes marked as 25 feet, but it really is just anywhere from the center to the edge would be 25 feet. And that'll help us out in our calculations. And then our last thing to remember is that if we consider this the ground, the height off the ground is 30 feet. So that means anything along this line is 30 feet. And with that in mind, let's actually go through the whole warm-up together. Just remembering this new information that the wheel makes a rotation every 20 seconds. Questions 1 through 5, I believe, on the warm-up are looking at this Ferris wheel and finding times and heights for all of these points around the Ferris wheel. So let's keep that in mind and let's try to label this out. Our times we'll come back to, but let's start with what we know. We know the height is 30 feet here at position A. And if that's my height off the ground, I know another place that is also 30 feet off the ground. I know another place on this wheel that's exactly 30 feet off the ground. So I'm going to mark it right here at F. We're 30 feet off the ground. Which means at 0 seconds we're 30 feet off the ground, but also that full rotation of 20 seconds, we're 30 feet off the ground as well. And then halfway around the wheel, we can think of as half the time or 10 seconds. And if we're able to mark that as 10 seconds, we can do even half of that and make that 5 seconds, which means the bottom of the wheel is 15 seconds. But let's see if we can break up these increments at B, C, D, E, and all of those. The top half of the wheel has 1, 2, 3, 4, 5 sections. So in 5 of these evenly spaced sections, we're going to mark out about 10 seconds. Well, if all 5 of these sections perfectly marks out 10 seconds, each section has to be 2 seconds. That means B is 2 seconds, C is 4 seconds, D is 6 seconds, E is 8 seconds, which brings us to that 10 seconds. So I'm just going to label the rest of the wheel as well. And we're going to come back to this idea in a little bit that B could also be, say, 22 seconds, and C could also be, say, 24 seconds. But let's go back to labeling our heights. We know the height to the center of the wheel is 30 feet, but I need to know this extra little piece right here, this extra piece from A to B. Well, we've been given this triangle that should help us figure it out. The angle of 36, we can think of the sine value. Oh, how did we get 36? We got 36 by looking at the entire wheel. This is just a tenth of the entire wheel. So it's like saying a tenth of 360 degrees. That's how we got to the 36. But now let's investigate how to use that 36. The sine of 36 is opposite over hypotenuse. So if we think of the opposite side as y, the hypotenuse is 25, we can set up that ratio, solve for y, and be left with 25 sine 36. And if you plug that into your calculator, you should get 14.7. So we know the height to A is 30. We're just adding on that 14.7, bringing us to a grand total of 44.7 feet at position B. And I love this Ferris wheel because I know another place on the wheel that is also 44.7 feet off the ground. Let's mark it. So we're going to use the same idea of the triangle to find other heights. You'll see your warm-up asks you to find 1 second and 3 seconds and 4 seconds. Let's think about 1 second. 1 second, we can't just say, oh, it's half the height. It's not half the height. Instead of being half the height, what it is half of the angle. It's half of the angle. So it's 18 degrees instead of 36. So we'll do that same process we did before, but with 18 instead of 36. We can also think about 4. 4 isn't double the height. 4 is double the angle. So instead of using 36, we're going to use 72. We're going to use that same process, 25 sine, but now of 72 instead of 36. That brings us to 53.8 feet. Don't forget, we're adding on that 30 feet from the ground to position A. And I know another spot on the wheel that's also 53.8, directly across D is 53.8, so we'll mark that one as well. We have almost everything we need now to fill in the wheel. So at this point, I do want you to pause this video, try the entire warm-up on your own, fill in everything on that table, fill in everything around the wheel, and it's going to come in really handy for the task. I want you to remember the wheel makes multiple rotations. It doesn't just stop at 20 seconds. It can keep tracing back over itself. So pause the video now, finish your warm-up, and then start the video when you're ready to keep going. Okay, so it's time to graph. The main difference between our warm-up and the task is just that we're going from a table and we're turning into a graph. So as we start 4.6, we're using the same Ferris wheel, radius of 25, center of 30, rotation every 20 seconds, and we're going to imagine ourselves rotating around the Ferris wheel. We start at A. When we start at A, what's our height off the ground? Well, 0 seconds, our height is 30 feet. So we're going to put that dot right there at 30 feet. Well, let's envision ourselves traveling in this Ferris wheel. 10 seconds later, I'm halfway around the wheel at position F. That's also 30 feet off the ground. So 10 seconds later, 30 feet off the ground. And 10 seconds later, I've made my full rotation of 20 seconds, so I'm back at my height of 30. But we don't just ride the Ferris wheel once, we actually keep going around. So 10 seconds later, I'm right back at that position F, 30 feet off the ground. And 10 seconds later, I'm right back at position A, my second full rotation, 40 seconds is 30 feet off the ground. So that's our first rotation of the wheel, that's our second rotation of the wheel. Now let's go for a third rotation of the wheel. Starting at 40 seconds, 10 seconds later, I'm right back at that midpoint of the wheel, position F. And 20 seconds later, at 60 seconds, I've come back full circle. And we'll stop it there. We'll say we went 3 full rotations on the Ferris wheel. So with this kind of like midline or guideline to start us off, let's fill in these other points we know. B, 2 seconds is 44.7 feet. So X value of 2, Y value 44.7, let's plot it. C is now 4 seconds, or 53.8. X value of 4, Y value of 53.8. And then let's graph the very top of the wheel. 5 seconds in is a height of 55. At this point, I'm just going to start to mirror myself. 6 seconds is 53.8, and 8 seconds is 44.7. So it's just going to mirror those same points. And I'm going to connect this as a smooth curve to get us started. So now with the points you found for the rest of the wheel, I want you to finish graphing. Remember that you don't just make one trip around the Ferris wheel. We make multiple trips around the Ferris wheel. So graph that through 3 full rotations of the wheel. And then I want you to look at question 3. Question 3 is a lot like question 7. They're asking almost the same question. They're asking you to check out the radius of the wheel. What if this was a really large radius, a couple hundred feet, a mile? That sounds crazy, but what if? What if it was a really tiny radius? What if this was now meant for a doll? It was just a little 1-foot radius. How would that change the graph? How would that change the equation? Now explore the height of the wheel. What if we lifted this way off the ground, put it on top of a skyscraper, super high off the ground? What if we dropped this really low, maybe like submerged it into the ground? If we changed the height, how would that change the graph? How would that change the equation? And lastly, what if we made that wheel rotate super fast? Instead of 20 seconds, the whole wheel rotates in 1 second, or really slow. Now the whole wheel rotates in an hour. How would we change the graph? How would that change the equation? So I want you to kind of think about that and think about the key differences. 3 is asking you specifically about the graph. What would look different in our graph for each one of these 3 things? 7 is asking you about the equation. What would look different in the equation for each one of these 3 things? Try that out and come see me during office hours, shoot me an email, ask a question on Google Classroom. Have some fun with this task, guys. Learn how to graph sine.